Hello everybody, in this lesson I will help you with your June exam preparation. I will also discuss question 7 of the 2021 exam paper. From the CAPS document, it's very clear that 35 out of the 150 marks are all dedicated to functions and graphs. So this means 23% of your paper is on functions and graphs. And then the bad news is that this is predominantly a grade 11 topic where you will discuss the parabola, the hyperbola, and the exponential function. And then there's only the grade 12 inverse chapter that was added here. Now, good news is I have prepared all those grade 11 chapters as a playlist for you on my channel. So you can search for it under hyperbola or the playlist name, or at the end of this video I added them, so you can just go click on the playlist and then watch the topics. Let's continue. Now this is the question. You will see that this is all about a parabola, a straight line, and suddenly they also added analytical geometry, which is actually a paper 2 topic. At the end of this lesson, you will find a playlist on the grade 11 analytical geometry as well. I suggest you pause the video, quickly do the question, and then you will find the answers. Question 7, the graph of f of x is x plus 4, x minus 6 is drawn below. The parabola cuts the x-axis at B and D and the y-axis at G. C is the turning point of F. Line AE has an angle of inclination of theta and cuts the x-axis and y-axis at A and E respectively. D is a point on F between B and G. 7.1, write down the coordinates of B and D. So what is happening at B and D? These are your two x-intercepts. And what's the rule? X-intercept make y 0. But in this case, you were very lucky because they already factorized it for you. So you simply take those two factors, you equate it to 0, you solve x, you get x is -4 and you get x is 6. But the question said specifically write down the coordinates of B and D. Therefore, you have to write them in coordinate form. So B is the point -4, 0 and D is the point 6, 0, and that is worth 2 marks. 7.2, calculate the coordinates of C. What is C? C is the turning point. So do you agree there at C you find a local minimum? And a local minimum is derivative equate to 0. Last year we had this formula x is minus b over 2a. But now that we can differentiate, let's rather do that. There's your equation. If you want to find the derivative there, you've got a problem, and the problem is that you cannot find it if there's brackets. So first of all, you have to multiply out the brackets, and then turning point is derivative equal to 0 for the x value, and then you find the derivative. How did I get to that one? Remember, you take this 2, it goes to the front, and you subtract 1. There on the x is an invisible 1. It goes to the front, it finds -2, it multiplies with it. There it's a 2 because you subtract a 1, and then remember the derivative of a constant is nothing. So there's your derivative. You equate it to 0 for maximum, minimum, and you find x to be 1. And then how do you find the corresponding y value of C, the turning point? You are going to take that x is 1 and you're going to substitute into the original equation. And there I wrote this down for you. Please note this is the correct notation. You write f of 1, and then everywhere where you find x, you're going to put the 1, and you substitute and you simplify, and you have to write your answer in coordinate form because they were asking for it. And then where's the marks? The marks are the x of the turning point, the y of the turning point. I'm going to write it there for you. It's 1, -25. That's your turning point. And now we're going to use that because on 7.3, they ask for the range of f. So how do we find a range? Range, you always start reading from on the y-axis from the bottom. So nothing is happening, nothing is happening, nothing is happening. And then suddenly there at -25, there you find your graph, and those values will satisfy your graph. So you want to answer, it's the y values from -25 upwards. And how do we write that in maths? There's two ways. You can either write it as y is an element, -25 included, semicolon, up to infinity, and don't include infinity, or you can write it as y greater and equal to -25. And any of the two, it's worth 1 mark for you. 7.4, given that theta is 14,04 and the tangent to f at t is perpendicular to AE. 7.4.1, calculate the gradient AE correct to 2 decimal places. So we are working out this gradient over there. In this sum, this is where they are using a little bit of your analytical geometry knowledge, where the definition for inclination is m is tan theta. So that is a formula that you can use. Theta was given to you, that is 14,04. And remember, m stands for the gradient. So you substitute in theta's place and you work out that the gradient of AE is a quarter, and that is worth 1 mark. So this gradient over there is a quarter. Number 4.2, calculate the coordinates of t. So let's just see what is happening. There at point T, they told us there's a tangent. Whoa, there's a tangent at the point T, and the tangent is perpendicular to AE. So what do we know? If we know that this line's gradient is a quarter, then the tangent's gradient we know is -4. And how did I get to that? You can say swap the numbers, swap the sign, or it's this little formula, m1 times m2 is -1. And then if the known gradient is a quarter, and then this is the one you want to calculate, you can work it out, and then you will find that your other gradient is -4. And then, now that you know the gradient of this line over there, we are looking for the x, or the coordinate rather, of t. So again, when we find the derivative, the definition is that the derivative is in fact the gradient of the tangent to a function. So our function was this parabola f of x is x squared minus 2x minus 24. And when we find the derivative there, we get 2x minus 2. And then derivative means gradient. And we know what the gradient is. So into the gradient, we substitute -4, and we have the derivative there. We equate them, we solve x, and we find that the x coordinate there at t is -1. And then every x has a corresponding y value. So in fact, this x there at that parabola's point is -1. So how do we get the corresponding y? We take the -1 and we substitute it into the parabola's equation. So into parabola, again, that's the correct notation, into the original. Don't substitute into the derivative, into the original equation, and we find the corresponding y there is -21, and then just be careful, answer in a coordinate form. T is the point -1, -21. And then where's your marks? Your marks are for finding the gradient of the tangent, for finding the derivative, for understanding derivative is the gradient of the tangent, for equating your tangent's gradient to the derivative, x value and y value. On 7.5, a straight line G parallel to AE cuts K at -3, -9 and R. Calculate the x coordinate of R. So first of all, let's just try and understand what is going on here. Do you agree the point B used to be the point -4 and the point D was the point 60 and the turning point was the point 1 and -25. Okay, so somewhere here there's a line that is parallel to our line AE that cuts F at a point K -3, -9. So I'm thinking if B is -4, then -3 could be somewhere there and -9 could be somewhere there. So let's just pretend that this point K, -3, -9 is lying there. And then what we know about it is that it is parallel to this line AE. So where shall we start? Let's start at finding the equation of G, because we are in fact for this point there, the point R, where the two graphs cut, the straight line and the parabola. First of all, when we find the equation of G, the straight line, we know now, they told us, that these two lines are parallel and therefore the gradients are the same. So I'm going to substitute into y is mx plus c. Why this one? Because we are finding G, a straight line. And then I know that the gradient of AE was a quarter, and now my line G is parallel to line AE, therefore it's also a quarter, the gradient. And then the point -3, -9 that lies on the line, I'm going to substitute it in. I will calculate C and I find the equation of the straight line G is a quarter x minus 33/4. Well, now I know what this straight line's equation is, and then I want to find this point R. And they told us there that this is the place where the parabola and the straight line intersect. And when two lines intersect, or not two lines, two graphs rather intersect, we can equate the two. So can you see, I took my line G, I equated it to the parabola, and then I'm going to solve x. I multiply it with 4 to get rid of the 4's here, and remember everything else has to be multiplied by 4. I get a little equation there, and then I factorize. And remember, if you can't factorize this one, no problem, use the quadratic formula. And your answer is x is 21/4 or x is equal to -3. Now what is going on here? X is 21/4. X is the same as 5,25. Now let's just think about this. Can you see there at D, this was a 6. So I think that this 5,25 looks as if it could be the answer. And why not minus 3? Because K was the point -3, -9. And this was the other place where the two graphs intersect. So this cannot be the answer. The only answer can only be 5,25. And then where's the marks? The marks are for knowing that the gradient of line G is the same as AE, which is a quarter, and then for substituting in the point -3, -9, your K value, and then giving me the equation of the straight line, equating the two, because there you knew that where the two functions intersect, you equate them, for getting your equation in standard form, and then for choosing the correct answer and stating that x cannot be -3.
The next question on this paper was finance. Click on the video in the left-hand corner to take you straight to the next lesson. And as promised, you will also find the playlist on parabolas, grade 11, and the analytical geometry playlist.